Welcome to this explainer. Today we're diving into a fascinating new research paper that asks a really critical question. Are our frontier AI agents actually synthesizing complex scientific data, or are they just repeating what they've already memorized? Researchers have just dropped a massive new evaluation framework called SCICONBENCH, and let me tell you, it fundamentally challenges a lot of the hype we're seeing around artificial intelligence right now. I'm so glad you're joining us today because we're going to break down exactly how this framework tests if AI can genuinely do the heavy lifting of scientific reasoning.
So here's our roadmap for this explainer. First, the AI Health Advisor illusion. Second, building the clean room. Third, how factual quality fails the test. Fourth, the cost and time trade-offs. And finally, auditing consumer AI agents. Let's get right into it.
Section 1. The AI Health Advisor illusion.
We're kicking things off by looking at the sheer scale of the situation, and honestly, the massive real-world stakes involved in AI-driven healthcare right now. This isn't just about chatbots writing your work emails anymore. It's about high-stakes, life-altering information. A staggering 200 million AI-powered health consultations have been reported by specialized clinical platforms like OpenEvidence. And OpenEvidence is a tool widely used by medical professionals, which really highlights the immense trust being placed in these systems for symptom and treatment exploration. The reliance on AI by the public and even practicing physicians is just absolutely massive.
We're undergoing a massive shift right now that kind of explains why this is happening. Think about it. In the past, if you had a medical question, traditional search engines just handed you the documents, right? You had to retrieve, read, and synthesize the information yourself. Basically, you did the homework. But today's agentic systems from OpenAI, Google, and Anthropic, they claim to do all that heavy scientific synthesis for you. They promise to filter out the noise, weigh the evidence, and just hand you a neat, expert-level conclusion. The danger here is pretty clear, though. If the AI filters the noise incorrectly, or worse, hallucinates the data, you are handed a highly convincing, but completely flawed medical conclusion.
Moving on to Section 2, building the clean room.
But here's the multi-million-dollar question. Are these systems actually synthesizing that data, or did they just find the answer key online? To figure out if these agents are genuinely thinking, researchers had to build a trap to catch them cheating. They call it the clean room. And as we can see outlined in the figures from this research paper, they use the Cochrane database of systematic reviews, which is essentially the gold standard in evidence-based medicine. They pulled over 9.11K to be exact, expert-written scientific conclusions. Then, they tasked the AI agents with answering the exact same scientific questions using open web tools. Finally, they evaluated the AI's generated conclusion against the expert's ground truth conclusion by breaking them both down into atomic facts. By atomic facts, I mean single, undeniable, measurable pieces of data that leave absolutely no room for interpretation.
So, the absolutely crucial point in all of this is avoiding what we call benchmark leakage. This is essentially when an AI takes a shortcut. Instead of doing the really hard work of reading multiple raw studies and reasoning through conflicting data to form a conclusion, the AI just uses its web search tool to find the exact Cochrane Review article where the human experts already did the work. It then regurgitates that memorized answer. It looks like genius synthesis, but actually, scratch that, it's really just shortcut retrieval. It's an open book test where they already have the answer key.
To prevent this leakage, the researchers built what they call SCICONHARNESS, which acts exactly like a biological clean room to prevent contamination. It strictly filters the AI's web access. It blocks any URLs from Cochrane domains. It hides search results with Cochrane in the title. It even goes as far as blocking any derivative articles published after the ground truth review's date. The AI is completely, literally cut off from the answer key. It is forced to look at the raw evidence and synthesize the science entirely from scratch.
This brings us to Section 3. Factual quality fails the test.
Now, what happens when you actually take away the cheat sheet? Let's start with the unfiltered data from the paper. We're tracking the Factual F1 score here, which is basically a combined grade of how many correct facts the AI found and how many crucial facts it missed. It's a perfect metric for judging real understanding. Notice how, when given free rein to browse the web without restrictions, models like OpenAI's O3 Deep Research and O4 Mini Deep Research sit comfortably high up, hitting F1 scores right around that 0.5 mark. We also see their cost plotted on a logarithmic scale here, showing relatively efficient performance when they can just search for the final pre-written answer.
But now, observe this dramatic shift. Once those clean room constraints are activated, almost all the data points just drop down and to the right. Look at how far O3 Deep Research and Claude Sonnet 4.5 fall. This performance attenuation proves a massive point. Much of their previous success was just shortcut retrieval. This isn't just a slight dip. It is a catastrophic collapse in accuracy,
when they actually have to read the raw data and formulate an original scientific conclusion without peeking at the published review, their factual quality just drops significantly. Under these strict, uncontaminated cleanroom settings, the absolute best frontier model currently available, O3 Deep Research, could only achieve a factual F1 score of 0.337. I want you to really think about that. Even the most advanced, specialized research agents are nowhere close to reliable when it comes to genuine scientific synthesis. And the reason this score is so shockingly low is because weighing conflicting evidence from multiple raw studies is a fundamentally different task than just summarizing a single review article. It proves that combining disparate facts, weighing evidence quality, and avoiding contradictions is still incredibly difficult for AI.
Section 4. The cost and time trade-offs. Let's see how this struggle builds into the physical resources required to run these agents. Because synthesis isn't just hard, it's also highly demanding on computing power. Looking at this figure, before the clean room is applied, you can see many of these models can spit out a scientific conclusion relatively quickly, often well under 100 seconds. And hey, for a chatbot interaction, sub 100-second latency is totally acceptable. They can work this fast simply because they're searching the web, finding a pre-written expert review, and summarizing it. Easy. But once the clean room blocks those easy answers, watch how the latency skyrockets. The OpenAI and Claude agents are pushed much further out on the timescale. Because they can't rely on pre-synthesized shortcuts, they are finally forced to engage in genuine multi-source reasoning. And the reason the time increases so drastically is that the agents get stuck in loops. They literally have to pull hundreds of individual papers, read them sequentially, and burn through API tokens trying to piece together a complex puzzle that no longer has a pre-written answer key available to them.
This reveals a pretty sobering reality check. True scientific synthesis by AI isn't just less accurate than we thought, it's a massive three-pronged failure when the guardrails are up. It takes much longer, it costs significantly more to run, and it ultimately delivers less accurate results. Stripping away the illusion of retrieval forces these models to work so much harder for a substantially worse outcome.
And that brings us to Section 5, Auditing Consumer AI Agents.
For our final section, let's pivot away from these specialized laboratory research models and audit the actual consumer agents that millions of people are using right now for medical queries. The researchers audited widely deployed consumer tools, and looking at this table from the paper, the results are incredibly revealing. Now, keep in mind, these models were tested without the clean room restrictions. They had full access to the open web and the ground truth answers. Yet, Google AI Mode, Google AI Overview, and even the specialized clinical tool Open Evidence all perform relatively poorly. Let's break down these metrics. Precision measures whether the facts the AI did state were actually correct, but factual recall, hovering in that 0.3 to 0.5 range across the board, is where the real danger lies. Recall measures how many of the necessary facts the AI managed to find out of everything it should have found. A score of 0.3, that means the AI is entirely omitting 70% of the critical information required to form a safe medical conclusion, even when the perfect answer is readily available online.
Now, what does a low F1 score actually look like in practice? Well, these real-world examples from the study show exactly how dangerous this is. On one side, an AI confidently states that the DASH diet is a powerful intervention with high-quality evidence. But the actual scientific ground truth says something completely different. The real science says the evidence is inconclusive, and the certainty is low to very low. In another instance, the AI claims an intervention produces meaningful reductions in BMI, when the actual science states it only slightly improves quality of life. The AI models are mischaracterizing evidence quality and sometimes inverting treatment effects entirely. No way around it. That's dangerous.
The researchers sum it up perfectly with this quote. Reliable synthesis of scientific conclusions remains an open challenge, and cleanroom evaluation is essential for assessing open domain AI agents. Despite all the incredible advancements in language models we've seen and all the marketing hype about autonomous AI researchers, we absolutely have to use these cleanroom evaluations so we don't trick ourselves into thinking AI is doing science when it's really just doing search. The era of the fully autonomous AI scientist, yeah, it has not yet arrived.
So I'll leave you with this final provocative thought to consider. If our most advanced AI systems still struggle to read raw data and form accurate scientific conclusions, even sometimes contradicting the very science they are citing, should we really be trusting them to make high-stakes decisions about our health? Thank you so much for joining me on this explainer. Keep questioning the data, and I'll see you next time.